So I'm very glad to have opportunity to give a talk today in OpenCS 2022. So my topic is open source software for RISC-V ecosystem. I'm Yanjun Wu from Institute of Software, Chinese Academy of Sciences. So here is my agenda. First, I would like to introduce myself. So I'm a research professor and also a chief engineer and director Intelligent Software Research Center. Here's my website. And what I want to say is I have three honorary positions, which are vice chair of Open EULA community, TNC member of Open Harmony community, and a former TNC member of RISC-V International. So all these honorary positions are related to my talks today. So I would like to introduce Open EULA, Open Harmony, and RISC-V in the next three slides. First is Open EULA, and perhaps outside the operating system field, few people heard Open EULA, but it's a rapid growing open source community. Open EULA's goal is to build an open source operating system for digital infrastructure. Now it has 100 support for mainstream computing architectures, including ARM, x86, and RISC-V, and also support devices like from server to cloud computing, edge computing, and even embedded devices. And now we have more than 11,000 contributors and 9,000 repositories and 99 system special interest groups. And we also have more than 70,000 users and 12 OS vendors. And ISCAS is also one of the 12 OS vendors. The next is Open Harmony. Open Harmony is another rapid growing open source community. And we may heard Open Harmony OS. And if you have a Huawei smartphone, according to the statistics from Huawei company, there are about 300 million smartphones have already installed, have already had Harmony OS installed. But Open Harmony is different from Harmony OS in terms of open source. It is built by several participators, including Huawei and ISCAS Thundersoft. So this community also has also very active. And you can see that there are more than 12,000 PRs and 20,000 stars, and many folks and contributors as well. And the third is the main topic of my talk today is RISC-V. And RISC-V, we all know, is open source instruction set architecture. So the rationale behind the RISC-V is very simple. That in the information technology field, we have many standards, open standards, like in networking field, we have TCP/IP. In database, we have SQL. But in instruction set architecture, we don't have open standard yet. We have 86 ARM, but it all belongs to the private company. So by far, as we see, that RISC-V is the most promising international ESA standard. So that's why I'm involved in RISC-V now. So this is a brief self-introduction. Next, I will talk about RISC-V and its foundation software. So let's go back to the definition of ESA. Some people say ESA is the dividing line and the interaction standard between hardware and software. But I see ESA is also the original point of an ecosystem. That means both software and hardware ecosystem is start from ESA. So let's go back to history. The history of ESA actually start from 1964. Actually, ESA was created for software compatibility and software hardware decoupling. About 1960s, IBM has 4 different machines, and they want the different software to run in the different machines. So Malkus, also the Turing Award. So he invented ESA at that time, and based on the RISC, Brooks invented the operating system known as IBM 360. So now we can see that ESA is actually to make the software compatible in different machines if they use the same ESA, same ESA, and also ESA decouple the software and hardware so they can evolve in parallel way, and they are not coupled together. And so I think that's original of ESA. So what is ESA? And I'll give us some samples of x86, and it's actually is like assembly code. And in the last column, also I give the example of ARM contains M ESA, like this table showed. So we can see that ESA is actually is many symbols that help us to coding. So what is RISC-V? This is from RVI, RISC-V International's website. It said RISC-V is a free and open ESA, enabling a new area of processor innovation through open standard collaboration. And the RISC-V ESA delivers a new level of free extensible software and hardware freedom on architecture, paving the way for the next 50 years of computing design and innovation. So the most important point is RISC-V is free and open, and also is designed for the next 50 years. So that's I think that's the major feature of RISC-V. So what actually RISC-V is? And we can see a table, this picture below, and that's all the RISC-V ESA instruction set architecture's menu. So the RISC-V is made of 3 parts: the base ESA, standard extension ESA, and the user customized ESA. So it is maintained by the RISC-V International. I will talk about later that we have translated the RISC-V menu and into Chinese. So why is RISC-V? I think there's 3 rationales behind the open source of RISC-V. The first is Moore's law is unsustainable, as we all know that according to the statistics from this year's chip manufacturing, The second is the complexity of system grows super linearly. As we see that Linux kernel now has some more than I think more than 17 million codes. So it's too complex that a single person cannot master it. So based on this, the third rationale is the few developers can master that complexity, both hardware and software. So not only software, but also hardware tends to be open source and customizable. So this is a trend that no one can ignore. Based on this situation, RISC-V become more and more popular. So as we see from the RVI website, we see also Dr. Quinn has also mentioned that RISC-V membership rapidly grows in 2020 and 2021. More than 130%. So where we are from the software perspective, this is timeline of the RISC-V involvement. but we are in 2022, and there are a lot of work to do. The most important work is software ecosystem software, as Dr. Quinn also mentioned. So what are they? I will talk about them in the next slides. Before that, let's say software. Why software is important? According to Chris, the founder of RISC-V and the Sci-Fi, the slides, the priority of RISC-V ecosystem has changed from 2020, from architecture to ecosystem software. Sorry, this is Chinese. So this is the status of RISC-V ecosystem, and we can see that the different levels have in software in different levels has already been ported on RISC-V from bootloader, hypervisor, operating system, runtime, and even the infrastructure software like Redis, MySQL, and also there are many applications also ported on RISC-V. So from this picture, we can see the RISC-V ecosystem looks like to be already rich. And another perspective is from the RISC-V software stack. So we look at this software stack from the development to the runtime. So we can see that RISC-V has many tools like GCC, LLVM, and QEMU, and we also have many open source firmware and also operating system like Linux. So this software stack can enable many applications in RISC-V ecosystem. So next part, I will mainly talk about what we are doing now in ISCAS. First, let's get a glance about ISCAS involvement and RISC-V. ISCAS started RISC-V related research from 2016. On 2018, PLCT stands for Programming Language and Compelling Tech Lab, was founded inside my center. It's Intelligent Software Research Center of ISCAS, to focus on RISC-V ecosystem software, especially for toolchains. Now PLCT has more than 100 people. We have more than 30 staffs and more than 70 students. On 2021, another team, Tasir, was founded for various OS support on RISC-V. Now Tasir has become the major force that maintains RISC-V support for Open Harmony and the Open EULA community, with more than 50 developers. So the PLCT team is now developing a SDK, a unified RISC-V development kit called RUI SDK. The RUI SDK consists of languages, compilers, toolchains, and IDE and emulators. And I will introduce one by one in the next few slides. The first is about the some core SDKs inside the RUI SDK. It includes QEMU, MLIR, LLVM, GCC compilers, and OpenGDK, also V8 JavaScript engine. And this consists of a different level of different tools like emulator, like system software development, and application software development. Some of work we have done in MLIR is and RV vector. We know that vector extension has been improved last year, December last year. So now we have the standard specifications. So we implemented RV vector in MLIR and submitted to the mainline. And we also do some auto vector optimization. And as application, we have applied RISC-V to OpenCV and improve the performance of OpenCV very largely portion. And we also optimized OpenCV DNN operators. And next is OpenGTK and the V8 and Node.js. And we got OpenGTK with RISC-V support on March 2022. And now GTK has RV32G and RV64G support. We also improved the execution performance. And what is very important, I think it's very important, is port V8 and Node.js to RISC-V, so that millions of web applications can run on RISC-V. So next is QMU and Spike. We implemented some extensions, standard extensions like PK for QMU and Spike, as well as other standard extensions. Now we can use QMU to emulate many chip vendors, many products from chip vendors like Nuclei and Star5 and T-Head. And that's important work is the help Android to boot up on RISC-V. PLCT team is the first team that have Android boot up on the RISC-V emulator. And after that, the teams from T-Head Alibaba make the full support of Android. And now we are trying to merge an Android for RISC-V to the mainline of Android's AOSP project. And the Android team from Google has already accepted some of the patches. So this is a current status of the Google AOSP Android open source project. And we have submitted some patches to the AOSP. So we at ISCAS deeply involved in RISC-V International. We are a primary member, just like ICT. CS ISCAS is also a primary member of RVI. And ISCAS is the only one training partner recognized by RVI in China. And we also the RISC-V development partner, one of 4 development partners of the world. And we have played many important roles in RVI, like RVI TNC member and chair of RVI ASA infrastructure, co-chair of code speed and size SIG, co-chair of packet SIMD task group. Mr. Wu is also a RVI ambassador in China, and he won 2 prizes this year as Technical Leadership Award and the RISC-V Community Contributor Award. Many members of PLCT ISCAS are active committers of the upstream software. They proposed many RISC-V related patches, like RISC-V vector extension, dialect in LLVM and MLIR project. Some of them has already been accepted and merged, and some of them has in widely discussion. We are also active organizers of a RISC-V community. We hosted 2 RISC-V World Conference in China. On 2021, we have the first RISC-V Summit China in Shanghai, and more than 1,500 people offline and more than 25,000 online, and more than 100 vendors, exhibitors. And this year, because of the pandemic, we have only online meetings, and the people, the participators is more than 100,000, and 10 new products were very important new products announced on the summit. We built a RISC-V lab infrastructure because there are a few RISC-V developer board. So many developers have no real board for development. So we built a remote RISC-V board lab, a cluster lab with more than 600 sci-fi hi-fi unmatched and 1,000 Naja D1. We gave free access with this application to the whole world. So this is this pictures from the RISC-V lab from Nanjing. We also have Wuhan office up and running on many RISC-V boards. We have like 4 places: Nanjing, Wuhan, Beijing, and Guangzhou. These 4 different places have different kind of operating systems installed on the RISC-V devices. We also did many works on RISC-V open source education and training. Till now, we uploaded more than 600 videos in Bilibili. So Bilibili is like YouTube. It's very popular in China. And about 500,000 watched. Although it's mostly in Chinese, but many people can watch it because it has it is video, so that people can also learn some technicals and procedures like how to install operating system, how to write a compiler, etc. So another important work is we lead a RISC-V system special interest group in OpenEULA and OpenHarmony community. We put up OpenEULA and OpenHarmony in D1. So the last work is we have Chinese translations for RISC-V ASA manual. We all know that ASA manual has involved because many standards have not been ratified yet. So we also update the Chinese version weekly according to the official version in English. There are more than 400 pages with the instruction manual, volume 1 and volume 2, and we will give it public in a few weeks. We also have GitHub and Git website, and they are synchronized, and we will also open the edit permissions so that many people can involve. So the last is conclusion. So the aim of our team is let RISC-V be the first class citizen of all major open source software. To achieve that goal, there are a lot of work to do, but we will continue to do what we can do. So here are some links about our team. The first is PLCT Labs link with all operating system and compilers internship available. And the second is open source promotion plan, which is initiated by ISCAS from 2020. And it's just like GSOC, like Google Summer of Code. the same form, and also open to the whole world. Any students from colleges can apply. And the last is a body compiler, is also an international open source project initiated by ASCAS. And we try to build more open and hardware, software co-design framework for the industry. So if you are interested in this project, please feel free to access link. So this is all my talk. Thanks for your time.